Welcome to this webinar session. In this session, we are going to be looking at three topics which are related, and I believe we should be able to complete them today. The first topic is on data sources. The objectives is that we want to know how data sources are classified, the peculiarity of each of those sources, and the best approach for choosing them. Generally, every activity of nature generates data, and this is why data is everywhere and is one of the greatest resources of nature. So data sources can be classified as internal or external data sources. Internal means that it is generated inside an organization or an institution. However, if it is generated outside of an institution, then it is external. We can also classify it as primary, secondary, or third-party data sources. Primary data sources is when the data is generated by the organization. Probably an organization or an institution has their own facilities, and those facilities generate all the data that is related to their operation. So such data is a primary data. If a data is collected by a researcher, probably through a survey or through a form of experiment, then it is also a primary data. And this requires some resources because an individual or organization will have to generate this data by themselves. So it will always require some resources, from digital to human resources. Secondary data sources is when data is collected by another organization, another institution, another body that is external to the user. It is usually a processed data, and they are usually published data, and it requires less resources because you do not need to collect the data by yourself, you just need to access them. A good example of this is data that are collected by big institutions like WHO, UNESCO, and co. These data are actually available in their databases, which researchers and organizations, government agencies can actually access with permission. Tertiary data source is usually referred to as the data that is collected by third-party vendors. So third-party vendors are those people who collect data for the purpose of selling it to those who will need it. So they collect data for business. So this data source is third party, and some refer to it as tertiary data sources. So the goal of a project will determine which of these options one will choose from. So if your goal is that in your organization, you just want to know how the sales has been for the last 1 or 2 years, the performance of your workers and co, you will have to use your primary data source, because those are the type of data that will contain such information. But secondary data source can be used if you are going to do a project that contains information, that requires information beyond the scope of whatever you are doing in your organization. So, for example, if you as a researcher, you want to work on data that is for different countries and co. Then you may have to go to some big NGOs and big institutions who actually have such data at their disposal. Then tertiary data source or the third party may be an option in some cases too. In conclusion, we have been able to look at how data sources are classified, the peculiarity of each of them, and the best approach for choosing them, which depends on the type of project that we want to do. Now, data is generated everywhere, but the point is that not all data is collected. So, in order for us to make use of data, we have to collect the data. And that is where we are about what are the forms in which data could be collected. Let's look at different forms of data collection, methods, why a data professional should be aware of them, and we look at some real-life examples. One of the most popular data collection methods, which has been in use for decades, is survey. And every one of us knows what a survey is. It's either we do it with somebody or we do it as part of a research or as part of our project on campus and co. However, today, survey has become more popular because even in the tech industry and other industries, survey is also very useful because if you want to know the best product for your customer, the best service for your customer, you will have to run some survey. There is something called user interview. With user interview, it is usually for a startup. So you want to start a new product and you do not really know what your customer wants. How do you go about it? You start by looking at people who will probably use your product and ask them what are those things they will want from such a product or from such a service. And that is a form of an interview, which is actually a form of data collection. So another form of data collection are the sensors. And we have spoken about sensors a lot in this series. And IoT devices. Today, the reason we have big data, that is enormous and voluminous amount of data available today, is because of sensors. Sensors are very important. For example, how do you think the weather stations are getting their data? They get it through sensors. So sensors are everywhere. In fact, the only reason why my computer can transform my voice into what you are hearing now is because of sensors. So sensors are very important in the digital era when it comes to collection of data. And a lot of data that you'll be having on the internet and so on and so forth, and even in big organizations, are actually data which are generated from sensors. So in our webinar on big data, I spoke a lot about what is called the IoT devices and how sensors work and the processors that actually process some of this data. And I said it then that when we want to talk about real life data processing or real life data analysis, sensors are the ones that are usually used for some of those processes. Then web scraping. Some of us may be hearing this one for the first time. Web scraping means that we can actually access a website and get information from that website, not just by copying and pasting it. So, for example, there are some packages in Python that I can use to access information from a particular website. So you can use some packages, you can use API. So for example now, if there is a page, a website page that has 20, 30 tables. So I can go to that website and open it on my browser and start copying and pasting that table into a place where I can start using the numbers inside it. But I can actually write a Python code that will actually go to that website in the backend and extract all of the table at once. So there is something like that. So we call it web scraping. And believe me, it is one of the most important ways of collecting data in this generation, because a lot of data are on the internet and they are on several websites. So instead of just doing it manually, one of the best way to do that is to use web scraping. So some of the people who will be doing our Python course, we are going to be teaching them how to use Python and some special packages in Python to do web scraping. So, but at least for us here, we should be aware of that. So if you have a lot of information on the internet that you want to get, instead of you to be copying and pasting manually, you can get a data engineer or an expert who can help you do web scraping and actually even automate it. Now, we also use API. API means application programming interface, and it's like a key between different softwares. For example, if you have an organization who have a lot of data in their database, and then another organization want to access some of the data. So one of the ways is that the organization who owns the data can actually get those data out from the database and send it to those who need it. The other option is to actually give another organization an open door to our system, such that they can enter the system, take anything they want, and come out. And that is where API works. So API, they are like keys that you can use to access other systems. And it is good that we are aware of this, but some of us will not be working with it because it's a very advanced concept in software development and in data analysis itself. It requires top level skill to be able to do that. And there are some regulations and security issues around it. Because if you give the API key of your system to an individual, it means you can do anything on that system. Then let us look at data stream. Data stream is a continuous flow of data which are generated from various sources in real time or in near real time. The word stream is familiar to us because some of us we stream videos online, we stream football and co. So data stream is very important now because if you want to do a real or a real-time analysis, you will need data stream. And a good example of this is, let's look at hazard monitoring and management. In some countries where they have a lot of tsunami, they have sensors in all of their society so that any change in the environmental condition can be picked by those sensors, and those sensors will send those informations to a particular center where each of those data is analyzed immediately. And that is why there can be an alarm that there is going to be an issue in the next 4 hours. That alarm is possible because as the sensors are generating those data are being streamed directly to another system that is analyzing them immediately. And so you can know what is happening in real time. So data stream is what they use in all of the big institutions like YouTube, Amazon, and co. So it is a very big component of data collection in the digital age. The banks, how do you think the banks can actually know if a wrong or a malicious transaction is about to happen? It is because everybody that is working, that is doing transaction on their system, there is a real-time collection of that data through streaming of the data, and there is a real-time analysis so that immediately an abnormal pattern starts showing up, there can be an immediate response. The same thing goes in cybersecurity and all other aspects of advanced and big tech industries. So it enables real-time analysis and decision making, like the examples I have given. Examples are social media streams and financial transactions. Data feed. Data feed is a delivery of data from one system to another, and it is usually at a particular interval. So it is also a massive movement of data from one source to another, but it is usually at interval. For example, if we have several companies all over the world, and let's say we have a company with several branches all over the world, and we want to have a central database that collects, where we store all the data from different branches. It doesn't make sense for us to do that every day. What we can do is that we can automate our system such that every Friday or every Friday night, those systems will collect data from all the databases in all our branches, and they will deliver them to our central database before the Monday of the following week. So such movement of data at interval or en masse at different interval is what is called data feed. So it is usually done in a predefined format. Predefined format in that we may not want all the data from our different branches. We may just want a particular type of data, probably the sales data or the financial transaction data is only what you need. So we are going to automate our system in such a way that it will only take those particular type of data into our destination, and other type of data, probably the customer data, employee data, all those ones will not be touched. Now, why should you be aware of all these type of data collection? It is because of their peculiarities. For example, if you want to use structured data or an unstructured data, there is a type of collection method you can apply. Cost. If you want to be doing data streaming, it's going to be very costly. And that is why some of those methodologies are used only by big companies who can afford top experts and can also afford expensive infrastructures. So some type of task will only be achieved using some specific data sources. For example, if you want to do real-time data analysis, data stream is your way to go. So you cannot use data feed to achieve that, because data feed will only get those data at a particular interval. So companies utilizing data stream and data feed, Netflix, you can understand why Netflix is doing that, because they have millions of users who are actually watching movies on their platform. Amazon, you know why? They have millions of users who are buying and selling on their platform. They have to do real-time analysis, or else they will lose a lot. Uber and some other transport companies, you can know where they do that, because for every distance that a car moves, there must be a record for it, and there must be some analysis for it. So you can understand why they use all these advanced level of data collection methods. And you can see the big boy, Twitter, and then YouTube. So in conclusion, we have been able to see different forms of data collection methods, the basic ones such as surveys and co, and then to the advanced ones such as the data feed, data streams, and co. And why we should know them as a data professional is because if you want to do a project or you want to advise a company, you will not advise a company that is just a small business to go and be buying an infrastructure that they will be using for data stream. It doesn't make any sense. And we have been able to look at some real life examples. Now, we have spoken about types of data sources. We have been able to look at different methods through which we can actually collect our data. The question is, how do we store our data? Because if we do not store our data, then the data is going to be lost. And if the data is lost, then all the resources that we have used to collect and gather them is a waste. And also all the information and all the gems that are present in that data is also lost. Like some expert says that data is the oil of the 21st century. Data is power. And because of all this importance of data, being able to store data appropriately is a big project in the data ecosystem and in fact in the whole IT industry. So a lot of facilities are coming up each day just to be able to achieve one goal: efficient storage of data. When some of us would have heard of the word cloud computing. Cloud computing is a whole new concept, and one of the cardinal importance of cloud computing is for efficient data storage. Now, what are data repositories? They are locations where data are stored, they are organized and maintained. If you have a company or an organization that has a good data repository, I'm telling you, as a data professional, your life is going to be so beautiful. Because when you have an organized data that is well maintained, the usage of data becomes very simple and straightforward. Now, let's look at common data repositories. We look at the commonest ones that even are used majorly in the academics and in small businesses are the flat files. I will still be talking about flat files as we continue in this session, but please, some of us are going to be working for small organizations, small businesses, and flat files are going to be what we are going to be taking advantage of when it comes to storing our data. So it is something that we are going to be talking a lot about, and you should be competent enough to store your data and preserve it well with flat files. By the time we talk about it, as we go on, we are going to understand better. The next is database. Every one of us here would have heard the word database before. So database is like the most popular place where data is stored, and over time, it has been used for decades. And then we are going to be talking about database itself as we continue. Then this one, I believe some of us wouldn't have had it before, data warehouse. So you remember warehouses in the industries and in the companies where they store all sort of equipment and everything. Data warehouse is basically like a place where you have several databases. We are still going to be looking at it later. And then we have data lake. And as you can see, this is a lake of data. We are still going to be talking about it. Now, which of these is going to be the best for my organization? One, the question is the type of data generated. If you are generating big data, they don't burn flat files well to handle them. So you will have to go for something else. What is it going to be as we continue in the session, you will know it. Type of analysis. We are also going to look at it. The budget of the company. If you have a small company, you can't ask them to go and build a data warehouse because they will go bankruptcy. And then the size of data generated. If you have a small company that does not generate so much data, flat files and probably small database will be useful. And then expertise. If you want, even for you to maintain a database, you will need an IT professional. Data warehouse, data lake, you are going to get a team, not just a professional. Now, let's look at the benefit of data repositories. Now, one, they help to maintain the long-term collection and usage of data in an organization. So when you have a place where we can say, let us look at what happened to our company 10 years ago, and you can go to a place and bring data of what happened 10 years ago out. That is what data repository does for a company. Companies also have different aspects. For example, we have the sales department, we have the customer care department, we have the marketing department, the employee department, the HR and co. When we have a central repository of data, we can carry data from all these different aspects and put them, organize them, maintain them in a very cool manner in a particular central repository. And this is very useful for data analysis and data usage. Scalability and storage, I've spoken about it, and centralized data management. And also data security and integrity. I will speak about integrity a little bit. You know, when you have a company where all your data are in Excel file, you know what happens? What happens is that when they say, oh, let us gather the customer record for the last 5 years, you know what people do? They will have to be copying and pasting from different Excel workbook. You know what that is? It is prone to error and is prone to a lot of data losses. Somebody can forget to bring a particular record out. Somebody can copy half of a particular page, and all sort of lack of integrity and validity. But when you have a central repository where the data is well organized, then integrity is surer. And when you have a data that is of high integrity and of high value, then it is going to enhance decision making. Now, let's look at databases. Databases are of two types. What we call relational database and what we call non-relational database. Relational database stores structured data, and Any one of us, some of us who have been following this program from the beginning, understand what a structured data means. Structured data means a type of data that we can store inside a table. So relational database basically means a combination of several tables, and that's what is stored in a relational database. However, there is what is called non-relational database, which is used to store both structured and unstructured data. So if we have video files, PDF files, audio files, we can store them in a non-relational database. But we cannot store a video file inside the relational database because we cannot put a video file inside a table. So the tables are connected with a relationship. And what is the meaning of a relationship? For example, we have a customer table that contains all our customers, their names, their geographical location, their zip code, and everything related to them. And then we have another table that contains our sales, which contains everything that each customer has bought, so that it contains the date of transaction, the amount the customer paid, and the time it was paid, and every other thing. But in the customer table, there is what is called the customer ID. So the customer ID is a unique value that is used to represent each customer. No two customers have the same customer ID. And then that same customer ID is also present in our sales table. Why? Because it is the customer in the customer table that also makes that also buy our products. So when a particular customer buy a product, we also store whatever they have bought with their customer ID. So it means that there is a customer ID in customer table, there is also customer ID in sales table. So because of this identical property, we can connect the two tables together. And that is what you call relationships in a structured database, so that we can connect 20, 30 tables together and we can take information from them. So we can say, okay, at this point, for this particular customer, we want to know only his address. And at the same time, we want to know how many times he has bought or how many times he has made transaction in the last 1 year. Those two informations are present. One of them is present in the customer table, another one is present in the transaction table. But we want to put the two information together in one place. So we can connect, we can write a query or a code that we generate, that will go into the two tables and generate our answer because of the connections between those two tables. Probably if you have time, I can actually show us some examples in our future webinars where I will actually do them using structured query language in my SQL. We won't be able to understand what I'm doing, but we see how it works in real life. So, non-relational database stores data in form of files, such as JSON file, XML file, and co. You don't need to know some of these things, but you should be aware of them, so that if somebody says JSON file, you should not look lost. And non-relational database can handle a large volume of data, and it is more complex, and requires a higher level of expertise. And these are the examples of relational database, and these are the examples of non-relational database. So databases can be local or cloud-based. So local database means we have our database inside our physical location, while it's cloud-based when we put it in the cloud. In the cloud means we let it be in another popular or public data centers, which is not in our environment. There are advantages and disadvantages of each of them, but we won't be talking about that today. Data warehouse. Data warehouse is, like I said before, is a combination of several databases, but it is for large volumes of data, but it must be structured data. And if you remember ETL process that we discussed in the previous videos and previous seminars, this is where they are useful. So the essence of this is that if you have a very big organization that cannot maintain all of their data in a single database, what do you want to go for? Data warehouse. Why? Because data warehouse can contain several databases. So we can say this database is for our customer transaction, this one is for our production, this another database is for our employee, and so on and so forth. And whenever we want to take a particular data, we can say, okay, go to this particular database and let's get it out. So data are stored in a categorical manner, like I've just explained. Data lake. Data lake is just like a dumping site for data. Some of us in our environment, we have that place where we dump our waste. That is where data lake is. When you have data streams and co, and data is coming from all over the place, like YouTube, Netflix, Amazon, all those big companies that are generating data in thousands of gigabytes per minute. What do? They just allow those data to go to a data lake, like a dumping site of data. And then experts can then come to that data lake and start taking and sorting them out in different manner. And data lake can contain anything, both the structured and the unstructured data. Anything can enter a data lake. It's like an ocean of data. Like I said, it's like a dumping set of data, and you can extract anything from it. So like ChatGPT, like I said before, like the type of data that was used to train ChatGPT was generated from data lake. So, and data lake is where we can store our big data efficiently. So when we get big data, where can we store it? It is data lake. And then flat files. Flat files are fundamental, they are simple, and they are the basic forms in which data are also transferred. An example of them are comma separated values, CSV files. I will do one seminar where I'm going to be showing us some of these, but it is going to be in our next course. So I'm going to be importing different type of data types like flat files into our Excel spreadsheet, and then I will be showing you how each of this looks. So each of these type of files, we can store our data in them, and the one you will know is Excel and Google Sheet. So I will also teach us in our next course how we can actually do and create an Excel database. And so these are the examples of flat files, and these are the other examples which, like I said before, we will not really have to talk about them, but we are going to be talking a lot about CSV and spreadsheets in the next session. So in conclusion, we have been able to see the type of data repositories that we have and their roles. We have been able to see some of the benefits and the common types that we have. In summary, we have been able to look at data sources, forms of data collection, and type of data repositories and their uses. So, if you know before, we usually finish this session by 9:30, but I discovered that majority of us, we don't ask questions. Since we have decided not to be asking questions, that is why I extended it to 9:45 today. If anybody asks questions, please let us quickly, you can unmute your mic and you can let me hear. Thank you. So there is no question as usual. And I said before that one of my professors said, your students don't ask questions. It is either they understand everything you have said or they don't understand anything. So I believe you understood everything. So after next time on Friday, we are going to be looking at another topic. And until then, I wish us all the best.
All right, sir. Thank you, doctor.
Thank you, sir.
Yeah.
It was a great time. Thank you.